Okay, let's go to part 2 of this. Now we are looking at friction of objects that are going up or down an inclined plane. So this is how an inclined plane is going to look like. So you've got this object. It's an angle of the theta. Now, at that angle of theta, we are going to have two components. If the object is going up, you can see the applied force is going up. Obviously, the frictional force is going to go down. But if the object is going down, which means you're going to have something that looks like this. I'm assuming that we are doing revision, so you have an idea what we are talking about. So our FA, which is applied, will be down. Obviously, our FR will be going at the top, which means that W sine theta is always going down, the incline, always, it never changes. And then you are going to have W here, and then perpendicular to the plane, at 90 degrees to the plane, you're going to have W cos theta, which is the one that is equal to what? Our normal reaction. Our normal reaction is equal to W what? Cos theta, which means we are never going to use W on its own, because we only use the values which are perpendicular to the plane as well as parallel to the plane. If this is the plane, we're only going to use values like that, which is your W sine, cos theta, and R W sine theta. And then here we are going to have your frictional force if the object is going down with the applied force. So we only use the ones which are perpendicular and parallel. We're never going to use the other ones. All right, let me just erase this. All right, so what are these forces? Two forces that we just learned about, the new forces that we've just learned about. This W sine theta is the force parallel to the plane. So if they say calculate the force parallel to the plane, I'm going to say it is Fs, because it's the force of sine, Fs, which is going to be a W sine theta. Okay, and then whenever they say calculate a perpendicular force, it's going to be WC, which is the cos, which is going to be your W cos theta. I think this is how they are mentioned on your formula sheet. Now, we get these things here, guys. Now, somebody's saying, but our value that was going up and down, we're using a sine, but the value that was going left and right, we were using a cos before. This is where we are getting that from. This is the W. And then if we want to find this value here, it means it will be the, because this one will be opposite, this one will be adjacent. So using our trig functions there, with this being the hypotenuse, that's how we get those W cos theta and W sine theta there. Okay, let's not go into that, but let's just know this. This is the force parallel, and this is the force perpendicular. All right. Now, with this done, let's not forget, what are we observing here? We said we are observing always equilibrium. Let me just get rid of this part here so that I do not run out of space. Right. Now, so I'm going to try to make this video less than 30 minutes. Now, what we need to do now here, that is very important as for us to understand equilibrium. Forces going up, NR, is equal to the force going down, W cos theta. Forces going left and right, FA is going right, is equal to your frictional force plus W sine theta, because they are both going in the same direction. This is how we are going to find NR and FA. Now, if you want to make FR the subject, then you know we have to transpose that W. Okay, but we are observing, again, I repeat, we are observing what? Equilibrium up and down and left and right of the plane with reference to this line, So it's up and down and left and right on that line. Okay, on the line of the plane. Just get rid of this. Now, what we need to now know is also something called the angle of friction. We need to know the angle of friction. How do we calculate the angle of friction? Or we also call it the angle of the slope. Angle of friction or the angle of the slope. We say it's just tan theta is equal to coefficient of friction. This is the angle of friction that you are looking for. Or the angle, you use the angle of the slope just when the object is about to freely fall without any force applied. Okay, we'll go through that. But what is important is that the angle of friction is this, which means our tan theta can further be what? Your normal reaction over the frictional force. Okay, frictional force over the normal reaction. Frictional force over the normal reaction. That's the value of the over the normal reaction. All right. Which is equal to what? Coefficient of friction. That's how we're gonna find that angle of friction. All right, let's move on to calculations now. We're gonna have a little bit of calculations here to do. Now, here's our problem and the diagram that corresponds with the problem. A body with a mass of 250 kilograms rests on a plane, making an angle of 12 degrees to the horizontal. Here's the 12 degrees. And the coefficient of friction is what? Is 0.36. First, let's find W. Where am I going with this? W is mg, which is equal to 250 multiplied by 9.8. This is where we're going to get the 2450 newtons. As you can see there, those are the values of W. First thing that is important. Now, A, find the gravitational component. Now, gravitational component are these forces. We also call them gravitational components. This, the one gravitational component parallel, gravitational component perpendicular, because they are due to the gravity. That's why we call them gravitational component, or we call them parallel component, a perpendicular component, right? So they say a parallel. Now remember, parallel, we said it is the one of sine, which is going to be W sine theta, which is 2450 sine 12, which gave us an amount of, if I have to punch this on a calculator, let me do that quickly. Sorry for that. It gives me 509. Please confirm my answers. 384 newtons, right? And then B, it becomes F perpendicular is the one of cos, W cos theta, which is 2450 cos 12, and it gave me an amount of 2396.46 newtons. Please make sure you confirm my answer. Now, they say, calculate C, the smallest force required to pull this object up, pull it up. So already our diagram is calculated with FA pulling the object up, which means we can simply use the diagram as given, which means FA is equal to, remember, forces going up are equal to the forces going down. So these forces going up are equal to the frictional force plus W what? What is that thing there? W sine theta. Okay, we are looking for FA. But before we can get the value of FA as written like that, don't forget what we said. Whenever we are looking for the force and we are given E coefficient of friction, we have to use the coefficient of friction, né? Which is, we said it is actually the frictional force over the normal reaction, right? So what will be the value of the frictional force here, and what will be the value of the normal reaction? Let's calculate it here. We said Fa is equal to the frictional plus W sine theta. Sorry for the handwriting. So we are looking for Fr, so we can substitute it here, which means Fr is going to be Fa minus W sine theta. Bring that down to Fa minus W sine theta. We already calculated it as 509,384. So we come substitute here. It's Fa minus 509,384 divided by, what is the normal reaction? Normal reaction is 16 calculator using up and down. So normal reaction is going up is equal to the force going down, which is going to be your W cos theta. Okay. So our normal reaction is equal to, we already calculated it as 2396,46. So we substitute it there at the bottom. 2396,46. Don't forget the frictional force is 0,36. When we cross multiply, we learn that Fa is minus 509,384 is equal to 0,36. Oh, pardon me, I even running out of space. 0,36 multiplied by 2396,46. Then what do? Just take this one and transpose it there. It's going to be a plus. So Fa is equal to, how is it going to be? It's going to be, this one is going to give us 862,726. Then plus the one that is coming this side, which is 509,384, which is ultimately going to give us an answer of how much? 1,000. What is that? 1,372,11 newtons. Please confirm Lama answer. Right. So we've got the force going up. What happens when you have got a force going down? Let me do that quickly because we don't have space. Now, a force going down, I'm just going to draw it here. This is also important to do. So you're going to have W sine theta, W cos theta. Now, since the object is, the applied force is now pulling it down, your frictional force will be there at the top. Right, we still have got the 12 there. So now, what's going to change is that, remember, we are looking for frictional force over normal reaction. So what is going to be our frictional force here? Fr is the only one going up, which means it's equal to Fa plus W sine theta, which is Fa plus U, which is going to be U. Remember, W sine theta, the same calculator is Ubani. Let's go up here. W sine theta, we go 509,384. All right, and then, so we've got Fr. Now we need to find what? UNR. Remember, guys, NR is just up and down. It's important to have a diagram. Please, it's important to have a diagram. It helps you a lot. NR is equal to W cos theta. Now, whereby we already know that NR or W cos theta, we go 2396,46 Newton. Now let's just substitute it there. 0,36 is equal to Fa plus 509,384 divided by, which is this? Oops, sorry. Divided by NR, which is 2396,46. Cross multiply. Fa You now know what to do. Is equal to 0.3 into 2396.46. Then it becomes exactly what we anticipate. FA is going to be equal to, remember this is going to give us 862.726, sorry, minus, because this one is now going to be positive. When you take it across, it's going to be minus 509.384. What do we get here? We get that the force applied, if you are pulling the object down, would be 353.342 newtons. Now, as you can see here, clearly, when you are pulling the object, up, you need a greater force because you are overcoming the incline. It's 1,372. But when you are pulling it down, you are also helped by the fact that the slope is also like in your favor when you are pulling this thing down. That's why you only need 353 newtons. That's how we solve this type of equation. Go through many of these questions. If you can do 5 or more, I think you're going to be safe when you're writing your exam. Now, here's a little bit more complicated one, whereby we are now looking at an oblique force on an incline surface. So remember, I'm gonna summarize this whole thing and then show you what is actually happening here. Now remember, an oblique force, we did it in the first video. If you don't remember it, please just go through the video. Now, as you can see, this object is being pushed at an angle of alpha. And then this is an angle of theta, which is our angle of repose. And there's an angle of alpha there, which is the angle of the force. Very important. The angle of the force is the alpha layer. But the angle of repose is the theta. Okay, we need to not mix those two. Because if we mix that, we're going to have a problem. Now, remember that FA there, the applied force that is at an angle, is going to have components. Now, the components are going to go into the direction at which it's being pushed at. You can't have components going like this, opposing that. They are going to be going towards the same direction, although they are not going to be in the same direction, but they must make something like this, which means this force is pressing down. F, applied force sine alpha. It's also pushing with FA cos theta for the object to do what? To go into that direction. So there are two components there. This one will be wrong. So also practice this a lot so that even if you know how to get your data, you really know how to use your data, okay? Now, these are the components when an object is pushing up an incline. I'm not going to be able to do the pulling up in the incline. You just need to know how to get the components right. You need to know how to get them a component to work right. Look at this one. Look at this one. Now, this one is an oblique force pulling down an incline. So this one is pulling down an incline. As you can see, the arrow is going there. It means it's pulling it down. But how many components are we going to have? Going to have that component and that component. Very important concept to be able to resolve this into components. Some will come here and do this. Still okay. This would be your W cos theta. That one would be your W, not W, sorry, force F. This one will be of force F sine theta. Okay. Please. I'm not theta alpha again, alpha, not theta, because theta is for the perpendicular and parallel components. Right. I'm just hoping, Uchi, if you understand how to resolve your forces, you're gonna be doing this much easier. Okay, since I don't have other explanations, maybe I can just go through this one, hoping the video won't be long. So I'm having this one, okay? Now, here it is, pulling it up an incline. Definitely, W sine theta will be here. Definitely, frictional force will be there. Definitely, my force T will be there. Let's just say it, so it was T, which means the force is parallel to this and perpendicular to this. This will be T cos alpha, because that will be the angle of alpha. That one will be T sine alpha. okay, if you are pulling it up and incline like that. You can still be pushing this thing down. I'm not sure if I have this type of a diagram, but there it is. If I can pull it, like push it like that as an angle alpha and say that is P, okay, force P, definitely the motion is going down, which means the frictional force will be here. And then don't forget this one is always here with W sine theta. And then, yeah, this would be all. But now here you are going to have two forces here. Let's change the color. Let's use blue. You're going to have a force like that and a force like that, which means here you're going to have P sine alpha. Here you're going to have P cos alpha. If this is the question, all right? So I've given you all the diagrams. All that is important, like I said once more, equilibrium. Upward forces equal to downward forces. You are looking for NR and we are looking for FR to substitute onto that formula, yeah? Frictional force. Okay. That is all that we are doing. Finding equilibrium and doing that. Let's look at the question. Here's the question. Says a body with a weight of, okay, so here already the weight is given. So we don't have to multiply by 9.3. So that's where 147 is. I'm sure the category is supposed to be 147. Let's go back to our red. Right. Now, is making an angle with the horizontal. Remember, 35 with the horizontal. And the force P, now, there's the force P. Making an angle of 80 with the horizontal surface. This is force P with an angle of 18. This is very, very important. Force P with the angle of 18. So that we don't mix these two. The coefficient of friction was found to be 0.25. Find P to push the object up the incline. So here you can see we are trying to push this thing up the incline. By applying a force at the bottom, we are pushing it up. So this is how the forces are going to look like. This is how the forces are going to look like. Now, don't forget what I told you. Coefficient of friction is frictional force over normal what? Reaction. Let's find the frictional force. Now, how do we find the frictional force? Frictional force is here. And we are going to say upward forces are equal to downward forces. Now, what are the upward forces? Or frictional force plus W sine theta, which is these two, they are going down, must be equal to the forces going up, which is what? P cos 18. Because P cos 18 is going where? Upwards. So we can now make FR the subject. Why are we making it FR? Because we want to substitute it here, guys. So FR is going to be P cos 18 minus 147 sine what? 35. So we've got FR. Now we're looking for NR. Upward forces equal to downward forces. Remember, NR is going where? Up. Is there any other force going up? I see this P sign is going down. I see that W is going down. So remember, perpendicular, we don't use this one because it's not perpendicular. It makes an angle of 35. We said we want the one that makes an angle of 90. Nale yenza 90. Nale yenza 90 going down. Okay? So we only use those angles. So NR is the only one going up, is equal to lay 147 cos 35 plus nale P sine 18. Now this is another equation for the normal reaction. Right, with these equations done, can I just remove this so that I can have space? I'm gonna remove this and erase the other stuff so that we can use that space to calculate. I don't want to go to a new page. Right, now we said it's theta is equal, or coefficient of friction is equal to frictional force over normal reaction. It's all about substitution and simplification. P cos 18 minus 147 sine 35 all over 147 cos 35 plus P sine 18. These two, we are substituting them there. Now, let us simplify. You should be able to simplify this and get what? From my simplification, I found out that this is going to be 0.951 P minus 84,316. All of that divided by, don't forget my frictional force here, coefficient of friction, sorry, 25. All divided by 118,925 plus the value of P will be 0.309 P. Cannot confirm lama value now. So this one will be 0.25. Then you cross multiply. You're gonna have 0.951 P minus 84,316 is equal to, wow, it's going to need a lot of space. It's going to need a lot of space. Let me just try and do it like this. I'm going to move a little bit here. 0.951 P minus 84,316 is equal to 0.25 into 118,925 plus 0.309 P. Right, then all we do is to, let's open that bracket, 0.951 P. I'm tempted to go straight to the answer because this is now mathematics, but let me not. Let's just simplify. Let's see how much are we going to get when we multiply. We're going to get, this is going to be 30,104. Plus, it's going to be 0.0773 P. Then let's arrange. Let's take this P to the other side and take that 84 will be positive this side. 0.951 P minus 0.0773 P is equal to 80,104. You have the liberty of pausing because I'm moving a little bit too fast. 84,316. Solve that. Let's see how much P is we're gonna have. Here I'm gonna have 0.874 P is equal to, if I subtract, add that, I get 114,42. I divide both sides by 0.8, you get P to be equal to what? 130,915 newtons. But what is key here? What is key here? Equilibrium. For me to be able to find these. The maths that follows, guys, it's N2 maths, it's N1 maths. So you need to know how to get NR and FR in terms of equilibrium. Upward forces are equal to downward forces. Number B, quickly. The force P to pull the object down the incline. Now we are pulling it down the incline. I hope the diagram is there. Yes, it is. So you are pulling it down. You are not pushing it. So when you are pulling something, you are holding it from the front. So I don't expect to see this force at the back. This force here, because you are pulling an object. So here it is. Here's the diagram. Again, formula, frictional force, coefficient of friction, frictional force of a normal reaction. So let's find the frictional force. Now the frictional force is gonna go backwards. Okay. Let's start with it. So frictional force. Is there any other force that goes upwards? Nothing. Is equal to the forces going down the incline or parallel to the incline. Nansle, nale. They are both going into the same direction downwards. P cos 18 plus 147, no comma, just sine what? 35. This is our FR. Maybe we can just simplify this thing over here. What would be cos 18? What will be cos 18? Let's punch that quickly. We already did it. We found it to be 0.951p plus that value there. We also did it and found it to be 84,316. So we already have this solved. We just substitute it. Then our normal reaction, there's our normal reaction. Let's write it. NR. Now, NR here is moving in the same direction with what? P sign. So they are going to add. P sine 18 is equal to what? Force going down. Remember, perpendicular. 147 cos what? 35. That's all. Now, we want to make NR the subject, which we need to transpose. 147 cos 38 minus P sine 18. Then let's simplify that. Let us simplify that. 147 cos 120,415 minus 0.309p. Now, can we substitute this into our formula? See what we're going to get. FR over NR, which is 0.25 into, I hope I get this thing like done fast. I don't have space, 0.951p plus 84,316, which is this, FR, all over the normal reaction of 120,415 minus 0.309p. Cross multiply. I get that it was 0.951p. Because I'm multiplying it by 1, it won't change. 84,316 is equal to 0.25. This one will need some simplification. Right, let's do the simplification. 0.951p plus 84,316 is equal to, if you open the bracket, then we get 30,104 minus 0.773p. Okay, here I put 0.0773. Okay, you are going to go through this, guys. Maybe I copied the wrong thing here, but I think the answers are the same. Let's focus more on the method. Right, and then from here we regroup, which means this one is going to come and subtract here. It's going to give us ubani 0.178p, and then when we take this one, what did we do? Oh, this one is 0.0. This one is 0.0. Yes. Is 0.0, yes. Okay, so it was correct. Right, and then let's transpose this one of negative. Where did I make a mistake here? All right, it's actually 0.7. Okay, I need to recheck this one. Let me just pause the video a little bit, and then I'm gonna recheck that one. I don't know what I did there. Oh, okay. I have redone the question. This one, obviously negative will come this side and add with the P, you get 1.028p. And then the 84 will come this side and subtract, you get negative 54,212. Then you divide both sides by 1.028, you get negative 52.74. Now, guys, we are not going to get a negative answer. The reason why we got a negative answer here is because I made up the question here B. The only question that they had there was A. So the one of B, I wanted to show you the different type of a question when they wanted to go down on A. So in this particular case, in your particular case, you would never get a negative force. Yes, so this was just a question that was made by me. to try and see what would happen if the question was changed from upwards to downwards. Okay, so you're not gonna get a negative answer. So this is it, guys. I hope that you've understood the concepts. But what is important in conclusion, as I write there, this is what I want you to, yay, this is what I want you to do, to know. I want you to know horizontal and parallel. Oh, sorry, not parallel, incline. On the horizontal, don't forget that you only have got, you've got this. They're going to ask you about frictional force. This is where you're going to be calculating about kinetic and static coefficient. F frictional force kinetic over normal reaction. F frictional force static over normal reaction. So this is the first question they can ask you here. The next question they can ask you here is with a force P or T at an angle of alpha. And then also remember, you've got your normal reaction and your W. Normal reaction and your W. Don't forget that. This is trying to be your FR. So you need to know how to answer this question and that question for horizontal. For inclined, you're going to have the basic incline, the angle, let W sine, let W cos, theta. Then if the applied force is going up, that means the frictional force will be going there. You need to know how to answer that question, whether it's going up or down. If it's going down, remember, FA FR is on the other side, right? And then another question that you need to know how to do is the one that we just done now, whereby we are talking about a force at an angle. Don't forget to W sine is always there, W cos is always there, and then here you're going to have alpha. You need to know how to answer this question as well. Whether this one is going down or up, whatever they can ask it, you just need to know. But on all these equations, guys, what is the bottom line? Let me write it in highlighted version. What is the bottom line? Equilibrium. This is the bottom line. Upward is equal to downwards, and the forces going to the left are equal to the forces going to the right, which comes to that conclusion of frictional force is equal to what? FR over NR. That's how you're going to find FR and NR, guys. I am done. Thank you so much. I hope this helps. Right.